Imagine standing on the equator, feeling perfectly still, yet knowing that beneath your feet, the Earth is spinning at over 1,600 kilometers per hour. That's right. Our planet rotates so quickly that everything around us is hurtling through space at an unimaginable speed, yet we feel nothing. This is the magic of physics, the invisible forces that govern our daily lives, making sunrise and sunset, seasons and weather all possible. Today we're going to explore the science behind this rotation, understanding not just the numbers, but what would happen if it suddenly stopped. The Earth spins because of how it formed 4.5 billion years ago, when our planet was a molten mass of rock, dust, and gas. It inherited the momentum of the swirling nebula from which it formed. As gravity pulled matter together, conservation of angular momentum caused the Earth to rotate. Think of it like a figure skater spinning, pulling arms in makes the spin faster. Stretching them slows it down. Over billions of years, this rotation stabilized, giving us the 24-hour day we take for granted. But how fast is it really spinning? At the equator, the Earth's surface moves roughly 1,670 kilometers per hour. That's faster than a supersonic jet, faster than anything humans have ever built. Near the poles, this speed decreases because the circumference of Earth is smaller there, but the effect is still significant. This spin is not just a number, it's a fundamental part of life on Earth. Without it, our atmosphere, oceans, and even the shape of the planet would be drastically different. Rotation is also what gives us day and night. As the Earth spins on its axis, different parts of the globe move into and out of sunlight. Without rotation, one side of the planet would be in perpetual daylight, while the other faced eternal night, drastically altering temperature, weather, and life itself. The Earth's spin also interacts with its tilt to create the seasons. Imagine the difference if we had no rotation. No regular sunrise, no rhythm to life, no biological clocks guiding humans, animals, or plants. But rotation does more than create light cycles. The spinning Earth affects weather patterns through the Coriolis effect, which makes winds and ocean currents curve instead of moving straight. This invisible force shapes hurricanes, trade winds, and even ocean gyres. Without it, weather would be radically different. Some areas might experience perpetual storms, while others could become eerily calm and stagnant. Rotation is like the engine of a clock, keeping time and motion flowing smoothly across the planet. Even the shape of the Earth owes much to its spin. The planet isn't a perfect sphere. It bulges at the equator, because centrifugal force pushes outward as it spins. This bulge affects sea levels, ocean currents, and even the distribution of gravity across the planet. Imagine how different life would be if the Earth were a perfect sphere, without the subtle flattening caused by rotation. Our oceans would redistribute, tides would change, and the geography we know would be unrecognizable. Earth's spin is also connected to its magnetic field. The movement of molten iron in the planet's outer core, combined with rotation, generates the magnetic field that shields us from cosmic radiation. If the Earth stopped spinning, the dynamo in the core would weaken, and our protective shield could falter. Radiation from space would bombard the surface, threatening life in ways most people have never considered. Even electronics, satellites, and power grids depend on this invisible barrier to function safely. Rotation also affects gravity, not in the way you might think. Gravity itself doesn't change, but centrifugal force from the spin slightly reduces the effective weight we feel. At the equator, we are a fraction lighter than at the poles. Imagine if the Earth stopped spinning. Suddenly, that centrifugal relief would vanish, and everyone would feel just a tiny bit heavier. It's subtle, but it's another reminder that rotation touches everything in our daily experience. Understanding the science of Earth's spin helps us imagine what would happen if it stopped. The momentum of everything on the planet, oceans, atmosphere, buildings, people, would suddenly have nothing to counter it. Our daily rhythm, the rise and fall of tides, the flow of wind, even the rotation of the core generating our magnetic field, would all be disrupted. In the coming sections, we'll explore exactly how catastrophic this could be. But first, it's crucial to appreciate how rotation quietly sustains life, order, and stability on our planet. So as you look up at the sky tonight, remember, we are riding a spinning globe at unimaginable speeds. Yet we feel nothing, thanks to billions of years of cosmic physics. It's a delicate dance, one that has allowed life to flourish, oceans to flow, and civilizations like ours to develop in perfect rhythm. And it's this very rotation, so often taken for granted, that we'll imagine being suddenly halted, to uncover just how fragile our world really is. Now that we understand the science of Earth's spin, let's imagine what would happen if our planet suddenly came to a complete stop. At first, it might seem like nothing would change instantly. After all, the ground beneath our feet feels solid, and our cities seem stable. But this is where physics becomes terrifyingly clear. The Earth spins at roughly 1,670 kilometers per hour at the equator, and everything on its surface, from oceans and air to buildings and people, is moving at that speed. If the rotation stopped, all that momentum wouldn't just disappear. Imagine the sensation of being in a car traveling faster than a supersonic jet, and suddenly hitting an invisible wall. Objects not anchored to the ground would continue moving at the same speed the Earth was spinning. Cars, buses, trains, and even planes in flight would be flung eastward with unimaginable force. Skyscrapers might collapse, bridges could snap, and entire forests could be swept away in an instant. Cities built for stability would face catastrophic destruction from a force invisible to the eye, but unstoppable in its power. The oceans would respond with equal fury. Water would surge violently from the equator toward the poles, no longer held in place by centrifugal force. Imagine walls of water hundreds of meters high sweeping inland, swallowing coastlines, ports, and islands. Coastal cities like New York, Tokyo, Rio de Janeiro, and Sydney would face near total devastation. Tsunamis of unimaginable scale would travel thousands of kilometers, reshaping continents and coastlines in just hours. The atmosphere itself would become a lethal storm. Air that had been moving along with the Earth would suddenly keep moving at supersonic speed. Winds faster than the strongest hurricanes ever recorded would sweep across the planet, ripping trees from their roots, overturning vehicles, and stripping the roofs from houses. Breathing in such conditions would be almost impossible, as clouds of dust, debris, and water filled the air. Even those far from the equator wouldn't be safe, while speeds would be slightly lower near the poles. Destruction would still be widespread. Mountains and other geological features wouldn't escape unscathed. Massive earthquakes could be triggered as the Earth's crust adjusts to the sudden halt. The redistribution of ocean weight and atmospheric pressure would send shockwaves through tectonic plates, causing volcanic eruptions, fissures, and landslides on a scale never seen before. The planet itself would tremble, reminding us that the Earth's spin is not just a convenience. It's a stabilizing force that maintains balance. Animals would be thrown into chaos. Migratory birds relying on wind currents for navigation might be killed instantly by violent storms. Marine life would be displaced or crushed by tsunamis. Land animals, including humans, would struggle to survive as their environment suddenly turns hostile. Even insects and smaller creatures would be carried away in the torrents of wind and water. Life everywhere would face a moment of unprecedented upheaval. Electricity grids, buildings, and infrastructure would be paralyzed. High-speed winds, flooding, and collapsing structures would destroy power lines, communication networks, and transportation routes. Hospitals and emergency systems would be overwhelmed immediately. In such a scenario, modern civilization would be brought to its knees in hours, showing just how dependent we are on the natural rhythm of a spinning planet. Interestingly, the initial halt would be the deadliest moment, but the effects would cascade. After the first few hours, Earth would settle into a temporarily new equilibrium, with water pooling at the poles, winds dying down as the atmosphere adjusts, and debris slowing to a stop. But the world left behind would be unrecognizable coastlines reshaped, forests and cities flattened, and millions, if not billions, of creatures displaced or lost. Understanding the immediate stopping effect makes one realize how fragile our sense of stability really is. The Earth's spin is not something we can perceive in daily life, yet it silently maintains order in every aspect of life, from the stability of our oceans to the very air we breathe. Without it, the planet would erupt into chaos in moments, demonstrating the invisible but vital forces that allow life to flourish. By the end of this section, we see that Earth's rotation is more than a clock, it's a shield, a stabilizer, and a silent guardian. Stopping it, even for just one day, would unleash forces beyond imagination, reminding us that the seemingly steady world beneath our feet is anything but static. Now that we've imagined the Earth suddenly stopping, and the immediate destruction that would follow, it's time to explore another terrifying consequence: the chaos of the atmosphere. The air around us moves with the planet's rotation, flowing in harmony with oceans and land. If the Earth came to a sudden halt, the atmosphere wouldn't simply stop. It would continue moving at supersonic speeds, creating winds of unimaginable force. These winds would be so powerful they could flatten forests, lift buildings from their foundations, and hurl debris like missiles across vast distances. Think about it this way. The air you breathe, the very atmosphere that nurtures life, is currently moving with the spin of the planet. At the equator, this is over 1,600 kilometers per hour. If the planet stops, that momentum doesn't disappear. It transfers into violent windstorms that circle the globe. In seconds, cities would experience winds hundreds of times stronger than a Category 5 hurricane, tearing apart anything in their path. Imagine standing on a street as entire neighborhoods are obliterated, and the roar of the wind is deafening, louder than any thunderclap you've ever heard. This wouldn't be just local chaos. Entire continents would be affected. The Coriolis effect, which normally directs winds and ocean currents, would vanish. Weather systems that have been stable for centuries would collapse. Storms would combine, twist, and grow into global superstorms. Hurricanes would stretch across oceans, tornadoes would appear inland, and winds would sweep from the equator to the poles with unstoppable force. The air itself would become a weapon, reshaping landscapes and altering climates in hours. Air pressure would also become chaotic. Regions near the equator would experience a sudden drop in centrifugal force, causing dense, fast-moving air to surge toward the poles. Polar regions, previously slower, would face massive air collisions as currents meet, producing storms beyond comprehension. These atmospheric upheavals would trigger secondary disasters. Fires, chemical releases from industrial zones, and massive dust storms burying entire cities under layers of debris. Even after the initial chaos, the atmosphere would not settle easily. Winds would eventually calm, but the redistribution of air, heat, and pressure would leave the climate permanently altered. Regions that were temperate might experience extreme cold or heat. Rainfall patterns would change dramatically, causing droughts in some areas and floods in others. The delicate balance of ecosystems, reliant on centuries of stable climate, would be shattered in a single day. Animals and humans alike would struggle to survive. Birds and flying insects would be instantly swept away by the supersonic winds. Humans caught outdoors would face almost certain death, while those indoors would contend with collapsing roofs, shattered windows, and flying debris. Cities and infrastructure were never designed to withstand wind at such speeds. No shelter on Earth could fully protect from the atmospheric onslaught of a sudden planetary stop. The air would also carry chemical and environmental hazards. Oceans would spray saltwater inland, dust storms would carry soil and volcanic ash, and industrial areas would release toxic gases into the air. Breathing would become nearly impossible in many regions. The atmosphere would no longer be a stable blanket protecting life. It would become a deadly, constantly shifting force. Interestingly, these chaotic winds could trigger long-term changes. Trees and plants could be uprooted, altering ecosystems and reducing carbon absorption. Weather patterns would stabilize differently, and new deserts or lakes might form as a result. The Earth's atmosphere is not static, it interacts with land, water, and sunlight. When rotation stops, this interaction is violently disrupted, leaving lasting scars on the planet. By the end of this section, it's clear that the atmosphere, something we usually take for granted, is entirely dependent on the Earth's spin. The very air around us is a dynamic system kept in harmony by rotation. Without it, windstorms, storms, and climate chaos would dominate, proving that the atmosphere is not just air, it's a fragile, powerful system, delicately balanced by the motion of our spinning planet. As we continue imagining the Earth suddenly stopping, the oceans are among the first and most devastating systems to react. Normally, Earth's rotation creates a subtle outward force at the equator, shaping the distribution of water and giving our planet its characteristic bulge. If that spin ceases, this force disappears, and the oceans would no longer be held toward the equator. Water would surge toward the poles in a catastrophic redistribution, flooding polar regions and draining equatorial zones. Picture it. Water hundreds of meters high rushing toward land, overwhelming coastlines, islands, and even mountains. Cities built near the ocean would vanish beneath waves, while entire continents might experience unprecedented drought as equatorial waters recede. The scale is hard to imagine, but think of the largest tsunamis ever recorded, then multiply that energy across entire oceans and continents simultaneously. Humanity has never faced a force of this magnitude. Tidal forces would also change drastically. The moon's gravitational pull currently interacts with the spinning Earth to create regular tides. Without rotation, tides would be unpredictable and far more extreme. Some regions could experience permanent flooding, while others might become barren dry beds. Ocean currents, which distribute heat around the planet, would collapse, dramatically altering climate patterns. Warm currents like the Gulf Stream would vanish, leaving regions near the poles bitterly cold and equatorial regions scorching. The sudden movement of water would generate mega-tsunamis, traveling at hundreds of kilometers per hour. These waves could sweep across oceans in a matter of hours, obliterating islands, reshaping coastlines, and erasing human settlements. Harbors, ports, and coastal cities home to millions would be the first to disappear, followed by inland areas as the displaced water moves further. Imagine the roar of water engulfing entire regions, carrying debris, ships, and soil along with it, turning the oceans into unstoppable forces of destruction. Marine life would face immediate catastrophe. Coral reefs, fish populations, and mammals would be disoriented or crushed by massive waves. Deep-sea creatures, accustomed to stable currents, would be subjected to violent shifts, disrupting the entire food chain. The oceans, which once sustained life and trade, would become a deadly, chaotic environment. Even species adapted to storms could not survive the sheer scale of water displacement. The redistribution of oceans would also have geological effects. Water rushing toward the poles would increase pressure on the Earth's crust, potentially triggering earthquakes, volcanic activity, and even the formation of new fault lines. Underwater volcanoes might erupt from the sudden change in pressure, adding heat and ash to the already chaotic environment. Coastal landscapes would be permanently altered, with valleys flooding and mountains partially submerged. Survivors on land would face a double threat, not only the physical destruction of the oceans, but also the climate consequences of altered currents and water levels. Regions once temperate could become arid or flooded. Crops would fail, and freshwater sources might be contaminated or displaced. Human civilization, dependent on stable coastlines and predictable weather, would struggle to adapt in just one day. Even after the initial surge, the oceans would not immediately settle. Waves would continue to slosh back and forth across continents, creating long-lasting flooding and chaotic currents. Shipping routes, coastal economies, and global trade would collapse as ports become unusable and harbors permanently reshaped. The Earth's waters, once a source of life, would demonstrate just how powerful and destructive they can be when freed from the balance imposed by rotation. Finally, the oceans going wild remind us that life on Earth is delicately intertwined with physics. The spinning planet keeps water in check, moderates tides, and shapes climate patterns. Remove that spin, even for a single day, and the oceans turn into forces of unimaginable fury, reshaping landscapes, destroying ecosystems, and threatening human survival. The oceans are alive in a way we rarely perceive, and their fury is a reminder of how fragile our existence is in the cosmic dance of our spinning planet. Now that we've imagined the oceans unleashed, let's turn our attention to the sky and the cycle of light. If the Earth suddenly stopped spinning, one of the most dramatic changes would be the freezing or scorching of day and night. Normally, rotation creates the rhythm of 24-hour cycles, giving us sunrise, sunset, and the comfort of alternating light and darkness. Without it, half the planet would be trapped in constant daylight, while the other half would face unending night. And the consequences would be nothing short of catastrophic. Imagine standing on the equator, looking east at the sun, and realizing it will never set. Hours, days, weeks, it doesn't matter. The sun remains locked in place. Temperatures would soar as solar energy bombards the surface without relief. Crops would scorch under relentless heat. Water sources would evaporate, and the land would crack like a desert. Animals, plants, and humans adapted to daily light cycles would be completely disoriented, struggling to survive in conditions they have never experienced. Meanwhile, on the night side, darkness would reign forever. Temperatures would plummet as the sun's energy no longer warms the surface. Ice would form rapidly, lakes would freeze solid, and plants incapable of photosynthesis would perish. The constant cold would stress ecosystems, and animals that rely on warmth or seasonal cycles would face mass die-offs. Life as we know it is built on cycles of day and night, and without rotation, that foundation crumbles. Even the atmosphere would respond to this new imbalance. Air on the sunlit side would expand from heat, rising and creating low-pressure zones, while air on the dark side would contract, forming high-pressure zones. Winds would rush from the cold side to the hot side, creating permanent, violent storms that could circle the planet continuously. The combination of extreme heat, freezing cold, and hurricane-like winds would make the surface nearly uninhabitable. Ocean currents, too, would be drastically affected. Water on the hot side would expand, raising sea levels locally, while water on the frozen side would contract, lowering levels and exposing land. Tides, already thrown into chaos from the loss of rotation, would add another layer of unpredictability. Flooding, droughts, and storm surges would occur simultaneously across the globe, reshaping coastlines in mere hours. The biological consequences would be devastating. Photosynthetic life, dependent on sunlight, would die on the sunless side, while animals and plants on the permanent daylight side would face dehydration, heat stress, and nutrient scarcity. Human survival would become a desperate fight, with migration toward the twilight zones, those thin edges between light and dark, being the only possible strategy. Even there, conditions would remain extreme. Mental and physiological effects on humans would be severe. Circadian rhythms regulate sleep, hormone release, and metabolism. Without the day-night cycle, humans would struggle to sleep, eat, and function. Panic, disorientation, and widespread chaos would sweep through populations. Societies already stressed by natural disasters, the oceans, fury, and atmospheric destruction would face an unprecedented crisis. Even after the 24-hour period of halted rotation, the recovery of day-night cycles would be violent. As the Earth begins to spin again, the boundary between extreme heat and cold would shift rapidly, creating storms, flash floods, and temperature shocks. Life would survive, but the world would be forever altered. Ecosystems would struggle to recover, and human settlements would need to adapt to the scars left by this temporary freeze of day and night. Finally, the day and night freeze reminds us how crucial Earth's rotation is to life. It is not just a measure of time. It is a stabilizing force, regulating temperature, weather, and biological rhythms. Without it, the very concept of day or night becomes a dangerous, life-threatening phenomenon. The sun and darkness, usually comforting constants, transform into instruments of destruction when the planet ceases to spin. By the end of this section, it's clear that the Earth's rotation is central to the balance of life. Day and night are not mere conveniences, they are vital systems, silently sustaining ecosystems, weather, and human civilization. When we take them for granted, we forget just how delicate this balance truly is. We've explored the oceans, the atmosphere, and the extremes of day and night. But now let's turn to another subtle yet profound effect of a sudden stop. Gravity. When we think of gravity, we often assume it's a fixed, unchanging force, pulling us steadily toward the Earth's center. Yet, in reality, what we perceive as weight is a combination of gravity and the centrifugal force caused by the planet's rotation. If the Earth stopped spinning, that centrifugal force would vanish, and the world would feel slightly heavier, just enough to change the way we move, build, and live. At the equator, the centrifugal effect reduces apparent gravity by roughly 0.3%. That may seem tiny, but it's significant on a planetary scale. Without rotation, everyone and everything would weigh just a fraction more. Humans would feel slightly heavier, carrying their own body mass differently. Athletes would notice the change immediately. Machines and vehicles would operate under different stress levels, and structures designed with rotation in mind might experience unexpected pressure. It's a subtle shift, but it's the first indication that the very forces holding us to Earth are interconnected with its spin. Gravity is also closely linked to the shape of the planet. Because the Earth spins, it bulges slightly at the equator and flattens at the poles. This oblate shape affects the distribution of water, the behavior of the oceans, and even the orbits of satellites. If rotation stops, the centrifugal force disappears, and the planet would gradually reshape toward a perfect sphere. Water currently held around the equator would begin moving toward the poles, creating massive floods in some regions and droughts in others. As we explored in the oceans section, mountains, valleys, and land masses would experience new stresses as gravity redistributes its pull, triggering geological events like earthquakes and landslides. Even the tides would change dramatically. Tides are primarily caused by the moon's gravity, but the Earth's rotation plays a critical role in shaping them. With a sudden stop, tidal patterns would collapse. The oceans would slosh unpredictably, creating destructive tidal surges in places that never expected them, while leaving other areas exposed to the air for the first time in millennia. Marine ecosystems, delicately balanced over centuries, would be thrown into chaos, with life struggling to adapt to rapid changes in water levels and currents. Gravity without spin would also affect human-built structures. Engineers design buildings, bridges, and vehicles with a precise understanding of weight and force. If the apparent weight of every object suddenly increased, some structures might buckle, cranes could fail, and even elevators would operate differently. Roads, vehicles, and machinery calibrated for one level of force would suddenly face unexpected stress. The effect would be felt globally, from the smallest towns to the largest cities, highlighting how intricately human civilization is tied to the natural laws created by our spinning planet. Even small objects would behave differently. Liquids would settle faster in containers. Pendulums would swing with altered timing, and airplanes or drones would require recalibration. Though these changes might seem minor compared to the chaos of oceans and winds, they illustrate that rotation touches every part of life, down to the tiniest detail. Gravity, while constant in theory, is subtly shaped by motion, and motion has been taken for granted for thousands of years. Beyond the physical, gravity without spin would also have profound ecological effects. Migratory patterns of birds and marine animals, which rely on consistent gravitational cues combined with rotation, could be disrupted. Plant growth, root development, and seed dispersal might also be affected as water redistribution, tides, and soil compaction change the environment. Every living system adapted to a spinning Earth would face a test of resilience. Finally, the combination of heavier apparent weight and sudden environmental chaos, extreme winds, tsunamis, temperature extremes, would create one of the deadliest aspects of a stopped Earth. Life is built for balance, and removing a single stabilizing force like rotation, which influences gravity, disrupts that balance in ways that ripple across ecosystems, human society, and even the planet's geological structure. By the end of this section, it's clear that gravity is not just a constant pull toward the Earth. It is a subtle, dynamic force, interwoven with rotation, shape, and motion. Stopping the Earth doesn't just freeze time, it changes the very weight of life itself, adding another layer of danger to a world already thrown into chaos. Beyond the oceans, winds, day-night cycles, and gravity lies another invisible but critical force that sustains life on Earth: the magnetic field. This protective bubble shields our planet from deadly cosmic radiation, charged particles from the sun, and solar winds. And it exists thanks to the spin of the Earth. Deep within our planet, a molten core of iron and nickel moves, driven by convection currents and the planet's rotation. Together, these forces generate the geomagnetic field that surrounds us. But what if the Earth suddenly stopped spinning? Without rotation, the dynamo effect of the core would falter. The molten iron would stop moving in the coordinated flow that produces the magnetic field. In mere hours, the shield protecting us from cosmic radiation could weaken drastically. Solar wind streams of charged particles traveling at millions of kilometers per hour would strike the atmosphere with full force. Satellites could be disabled, communications disrupted, and the power grid vulnerable to massive electrical surges. On the ground, radiation exposure would increase, especially at higher altitudes, threatening both life and technology. The consequences for humans could be profound. Our atmosphere offers some protection, but without the magnetic field, charged particles from space could strip away layers of the ozone, damage DNA, and increase cancer risks. Even short-term exposure could create problems for electronics, aviation, and space travel. Astronauts in orbit, satellites, and space stations would be at extreme risk as the magnetic shield faltered. The very tools we rely on to observe and navigate the world would become unreliable in an instant. Interestingly, the magnetic field interacts with the atmosphere and oceans too. Geomagnetic forces help guide currents, influence the auroras, and even affect animal navigation. Birds, sea turtles, whales, and even bees rely on subtle cues from the magnetic field for migration and movement. A sudden collapse of the field could confuse animals, disrupt migrations, and destabilize ecosystems, compounding the chaos already caused by spinning stopped winds and surging oceans. Even the Earth itself would feel the effect. The molten core's motion helps regulate internal heat flow and the planet's overall stability. If rotation stops, the internal dynamics of the core could shift, creating stress in the mantle. This might trigger earthquakes, volcanic activity, and even minor shifts in tectonic plates, adding another layer of disaster on top of already catastrophic events. The core, usually hidden from view, becomes one of the most critical yet vulnerable systems in the planet's survival. Auroras, usually beautiful and harmless, would become ominous signals. With the magnetic field weakened, the northern and southern lights could spread across latitudes, illuminating the sky with unprecedented intensity. At the same time, these glowing displays would signal the danger of radiation surges impacting life on the surface. It's a cosmic reminder that our planet's magnetic field is a fragile, yet vital barrier between life and the harsh realities of space. Even short-term disruption of the magnetic field could have technological consequences. Communication networks, GPS satellites, and power grids are all tied to geomagnetic stability. A sudden stop in Earth's rotation would ripple through our technological world, potentially causing blackouts, satellite failures, and chaos in navigation and transportation. Civilization relies not only on physical stability, but also on the invisible forces maintained by our spinning planet. Finally, understanding the core and magnetic field emphasizes just how interconnected Earth's systems are. Rotation is not just about day and night, or wind and water. It's the engine driving the molten heart of our planet. Stop the spin, and the magnetic shield falters, exposing the surface to cosmic forces we rarely think about, reminding us how delicately life depends on this invisible, protective envelope. By the end of this section, it's clear that the Earth's core and magnetic field are silently keeping us safe, regulating everything from cosmic radiation to animal migration. Stopping the planet is not just a physical catastrophe, it's a cosmic one, shaking the invisible defenses that make life possible. We've explored the oceans raging, winds tearing across continents, extreme day and night, gravity shifting, and the magnetic field faltering. Now, let's turn to perhaps the most relatable consequence: human survival and civilization. How would societies endure a single day where the Earth stops spinning? Even in idealized scenarios, the answer is sobering. The delicate systems we rely on for life, food, water, shelter, and energy would be tested to their limits. The first challenge would be the physical destruction left by sudden halts, violent winds, and tsunamis. Entire cities, especially coastal ones, could be wiped out within hours. Skyscrapers might collapse under altered gravitational stress. Bridges could snap, and roads would become impassable. People unprepared or caught outdoors would face almost certain death. Emergency services, even in the best prepared countries, would be overwhelmed. Hospitals would struggle as infrastructure fails and communication networks collapse under the strain of chaos. Survivors would face an entirely new environment, with oceans redistributed and winds destroying much of the infrastructure. Freshwater sources might be contaminated or buried beneath debris. Agricultural systems would collapse as fields flood or dry out depending on their location. Urban populations, often reliant on centralized water, food and electricity, would find themselves without basic necessities. Even rural areas would face hardship, as extreme weather and disrupted ecosystems make traditional survival difficult. Food scarcity would become a critical issue. Crops already stressed by temperature extremes, scorching on the sunlit side, frozen on the dark side, would fail almost immediately. Livestock might be lost to flooding, freezing, or heat. The global food chain would be fractured, and transportation systems would be crippled, making relief and aid nearly impossible. Survival would depend on local resources, ingenuity, and cooperation. And even then, casualties would likely be high. Energy systems would also collapse. Power plants, electrical grids, and fuel supplies are all sensitive to environmental disruption. Nuclear plants could face catastrophic failures if cooling systems are compromised. Solar power would be concentrated only on the sunlit side, while the dark side would go without. Fossil fuel distribution would falter as roads and ports are destroyed. Without electricity, heating, refrigeration, communication, and medical care would be severely limited, compounding the survival crisis. Social order would be tested like never before. Panic, fear, and scarcity could drive people to desperate measures. Communities might fragment, while others band together to share resources and protect one another. Governments and emergency organizations would be challenged to coordinate in a world where communication is disrupted and infrastructure is decimated. Historical examples of disasters show that human behavior can swing between incredible altruism and alarming chaos, and a planet that has stopped spinning would amplify both extremes. Some humans might survive through preparation and luck. Underground bunkers, fortified shelters, or isolated locations could offer protection from the worst effects of wind, water, and temperature extremes. Remote communities near twilight zones, the thin edges between permanent day and night, might find the most habitable conditions. But survival would not be guaranteed. Even small mistakes could have fatal consequences. Technology and science would play a critical role. Satellites may fail due to magnetic disruption and atmospheric chaos, making navigation and communication difficult. But local innovations, manual tools, emergency systems, and ingenuity would become the keys to enduring the crisis. Humans have adapted to extreme conditions throughout history, but nothing compares to the scale of this planetary catastrophe. Finally, this scenario reminds us of how fragile civilization really is. Our cities, energy grids, food production, and social systems are all designed around the predictable spin of the Earth. One day without rotation could destroy decades of progress, reminding us that stability is not guaranteed. It is maintained by forces often invisible to us. Humanity's survival would depend on resilience, adaptation, and ultimately, a respect for the delicate balance that rotation provides. By the end of this section, it's clear that human civilization is intricately tied to the spin of the planet. From food to infrastructure, from social order to technology, everything relies on the Earth's rotation to function smoothly. Without it, life becomes a struggle for survival on a scale never before imagined, forcing us to confront just how dependent we are on forces we rarely perceive. After enduring the catastrophic chaos of a day without rotation, raging oceans, supersonic winds, extreme day and night, disrupted gravity, and a faltering magnetic field, the thought of Earth starting to spin again might seem like a relief. But restarting the planet is not a gentle process. In fact, the reintroduction of rotation would bring a new wave of challenges, dangers, and unpredictable consequences. Imagine the planet slowly regaining its spin. Everything that had been flung outward or left adrift the oceans, The atmosphere, debris, and even humans would suddenly be affected by the return of centrifugal force. Water that had surged toward the poles would begin to redistribute, creating massive currents and tsunamis flowing back toward the equator. The atmosphere, already in chaos, would accelerate, creating unprecedented hurricane-strength winds sweeping across continents once more. In essence, the relief of spin comes with a second wave of destruction. The sudden restart of rotation would also wreak havoc on gravity's delicate balance. Structures already weakened by the temporary stop would face new stress as centrifugal forces return. Buildings, bridges, and dams that survived the initial halt might buckle under the shifting forces. Vehicles, aircraft, and ships would need to adjust to changing conditions instantaneously. Even individuals on the surface would feel subtle shifts as their weight and balance are momentarily altered. The planet is not a static stage, it is a dynamic actor, and its spin dramatically influences every detail of life. Oceanic currents and tides would remain unpredictable for weeks or even months. Water surges could create new coastlines, erode old ones, and reshape islands permanently. Storm systems would continue to form and collide, producing chaotic weather events that might linger long after the rotation resumes. Fisheries, freshwater supplies, and marine ecosystems would struggle to recover, with countless species displaced or lost during the upheaval. The day-night cycle would also undergo extreme readjustment. Those regions previously trapped in permanent sunlight or darkness would suddenly experience movement of the sun across the sky. Extreme heat from the sunlit side might meet freezing temperatures from the dark side as rotation reintroduces the familiar rhythm of day and night. Rapid temperature changes could trigger flash storms, sudden snow, or scorching winds, further stressing the fragile ecosystems and human settlements. Even the Earth's magnetic field would begin to recover, but not immediately. The molten core would gradually resume its dynamo motion, slowly restoring geomagnetic protection. During this transition, satellites, communication systems, and power grids could remain vulnerable to cosmic radiation and solar activity. Recovery would take days to months, leaving life exposed to lingering hazards even after rotation returns. Humans would face a second survival challenge. Those who endured the first day of chaos might now have to navigate a shifting landscape of water, debris, and collapsing infrastructure. Cities partially rebuilt or surviving from the initial stop could face destruction anew. Emergency relief and humanitarian aid would struggle to reach affected populations, and societal stress would compound. The psychological toll on survivors would be immense, as hope of normalcy clashes with the reality of ongoing catastrophe. On a longer timescale, the resumption of spin would begin to restore balance to ecosystems, climate, and human infrastructure, but only slowly. Rivers would find new courses, winds would stabilize, and day-night cycles would regulate biological rhythms. Life would adapt, but scars would remain. Coastlines reshaped, forests leveled, and species lost forever. Civilization would endure, but the memory of one single halted day would serve as a cautionary tale about the fragility of our world. Finally, the scenario of Earth starting to spin again underscores a profound truth. The planet's rotation is not merely a convenience. It is the engine of balance, the silent force that governs water, air, gravity, magnetic protection, and life itself. Disrupt it even for a day, and the consequences ripple across every system. Reintroduce it, and the Earth itself must readjust, reminding us that stability is a delicate equilibrium maintained by forces we often overlook. By the end of this section, it's clear that the return of spin is both a blessing and a challenge. Life would survive, civilization could rebuild, but the world would be forever altered by the violent reminder that rotation is the invisible heartbeat of our planet. As we reach the final section, Let's take a step back and reflect on the profound lessons of a world where the Earth stops spinning for just one day. We've imagined oceans surging, winds of unimaginable force, extreme day and night, shifting gravity, a weakened magnetic field, and the struggle of human civilization. Now it's time to explore what these scenarios teach us about the fragile balance of our planet, and to imagine some what-ifs that push our curiosity even further. One of the most obvious lessons is how interconnected Earth systems are. Rotation is not just about marking hours or creating day and night. It influences gravity, the oceans, weather, magnetic protection, and even life itself. A disruption in one aspect like halting spin cascades across multiple systems in ways that are both dramatic and unpredictable. It's a reminder that our planet is a complex, dynamic organism, and humanity relies on forces often invisible to survive and thrive. The scenario also teaches humility. We often think of civilization as invincible, but a single planetary stop demonstrates how dependent we are on natural laws. Our cities, energy grids, agriculture, and social systems are all calibrated to a spinning Earth. Remove that stability, and even advanced societies could face catastrophic consequences within hours. It's a stark reminder that nature operates on scales far larger and more powerful than human planning. What if scenarios can also stretch our imagination in fascinating ways? What if the Earth stopped spinning for a week instead of a day? The disasters would multiply exponentially, oceans permanently displaced, the atmosphere violently redistributed, entire ecosystems collapsing, and human populations decimated. What if only certain regions stopped rotating, creating zones of chaos next to stable areas? The imbalance in climate, ocean currents, and wind patterns would produce bizarre weather, strange tides, and massive ecological disruption. These thought experiments allow us to explore the limits of our understanding and the resilience of life. Another interesting angle is the potential technological response. Could humanity engineer solutions to survive such a disaster? Underground cities, massive barriers against waves and winds, or artificial rotation stabilizers are ideas that, while fantastical, spark the imagination. Could we ever counteract forces as vast as a planet's inertia or magnetic collapse? These questions challenge scientists, engineers, and storytellers alike, pushing the boundaries of our creativity. The psychological impact of a stopped Earth is equally fascinating. Imagine witnessing a permanent horizon of sun or darkness, oceans moving as living walls, winds that scream like instruments of apocalypse. How would humans cope? Would communities come together in unprecedented cooperation, or would panic and chaos dominate? Such scenarios force us to reflect on human resilience, ingenuity, and adaptability in extreme conditions. Even ecological what-ifs provide endless intrigue. How would animals adapt to permanent day or night? How would plant life cope with shifting tides, winds, and gravity? Could ecosystems evolve rapidly in response to these pressures, creating entirely new forms of life in a single day? While purely speculative, these questions highlight the delicate balance life maintains on a spinning planet. Finally, the story of a halted Earth reminds us to appreciate the ordinary. The predictable sunrise and sunset, gentle ocean tides, seasonal winds, and the invisible force of gravity are miracles we take for granted. Rotation is a silent architect of life, a stabilizing rhythm that allows civilizations to flourish, ecosystems to thrive, and humanity to exist at all. Imagining its absence deepens our awe for the planet's complexity and fragility. By the end of this section, we realize that exploring what-if scenarios is not just about imagining disaster. It's about understanding the intricate balance of nature, appreciating life's resilience, and inspiring curiosity. The Earth's spin may seem mundane, but it is a force of profound importance, shaping every second of life on this planet. Thinking about what would happen if it stopped, even for one day, reveals both the power of natural forces and the fragility of everything we hold dear. As we close this journey, we're left with a mixture of wonder, fear, and respect. The Earth is a marvel of physics, biology, and cosmic design. Rotation is its heartbeat, and without it, life as we know it teeters on the edge. So the next time the sun rises or sets, remember, we owe the rhythm of our days, the stability of our oceans, and the survival of life itself to the spinning dance of our incredible. So far, we've imagined a day where the Earth stops spinning, exploring immediate chaos, oceans surging, winds tearing through cities, day and night freezing, gravity shifting, the magnetic field weakening, and humanity struggling to survive. But what happens after the dust settles? What long-term effects would a single day of halted rotation leave on the planet itself? Even one day of this extreme event would alter Earth permanently, reshaping landscapes, climate, and ecosystems for decades or even centuries. Let's start with the geological impact. The sudden redistribution of oceans, combined with altered gravitational forces, would stress tectonic plates in unprecedented ways. Fault lines might crack, triggering massive earthquakes far from their usual zones. Volcanoes could erupt due to pressure changes in the crust, sending ash and lava across regions that have never experienced such activity. Mountains, valleys, and riverbeds might subtly shift as the planet adjusts to the new balance of forces. Even after rotation resumes, the Earth's surface would bear the scars of a single catastrophic day. The climate would also undergo long-term transformations. Oceans, initially displaced toward the poles and then returning to equilibrium, would create altered currents. These currents are the lifeblood of global climate, distributing heat and regulating weather patterns. Disruption could cause permanent changes. Deserts expanding, rainfall patterns shifting, and storm belts forming in unexpected regions. For instance, areas that once thrived agriculturally might become arid wastelands, while previously frozen zones could see mild, unexpected climates. The Earth's weather systems would take years to stabilize fully. Marine ecosystems would be profoundly affected. Coral reefs destroyed by tidal surges and violent currents might take centuries to rebuild, if they survive at all. Fish populations displaced by ocean chaos could collapse or migrate to new regions, creating ripple effects up the food chain. Whales, dolphins, and other large marine mammals that rely on migration and currents for feeding would be forced to adapt, potentially leading to new evolutionary pressures. The oceans would slowly reclaim balance, but life within them would never be the same. The atmosphere, too, would undergo lasting change. Winds that tore across continents would reshape forests, erode soil, and create new deserts or floodplains. Tornadoes and storms formed during the event could leave permanent marks on landscapes, carving canyons or depositing sediment across regions. Even after rotation resumes, the atmosphere's behavior might be slightly altered, producing unusual storm patterns and unpredictable weather for years. Earth's magnetic field, disrupted during the halted day, might take decades to fully stabilize. While the molten core would eventually return to normal rotation, temporary weakening could leave traces in the geological and atmospheric record. Cosmic radiation exposure during that period might subtly affect species evolution, leaving an invisible legacy of the event for millennia. Human civilization, though resilient, would also face long-term consequences. Cities rebuilt after the initial destruction might have to adapt to altered coastlines, higher or lower sea levels, and climate shifts. Agricultural systems would need redesigning to cope with new rainfall and temperature patterns. Economies would face years of recovery, as trade routes, infrastructure, and industries adjust to a world physically reshaped by one day of planetary pause. Even ecosystems on land would evolve in response. Species displaced by floods, heat, or cold might colonize new areas, creating different ecological balances. Forests, wetlands, and deserts would shift as nature adjusts to altered water distribution and wind patterns. Predators, prey, and plants would all face selective pressures, shaping the biosphere in ways unimaginable before the event. Finally, the psychological and cultural impact on humanity would be profound. Stories, myths, and historical accounts of that single day could redefine civilizations, inspiring caution, awe, and new philosophies about the fragility of life and the planet. The memory of a day when the Earth paused would remind future generations that stability is not guaranteed, and that even forces as fundamental as rotation can be disrupted, whether by cosmic events, human imagination, or theoretical scenarios. By the end of this section, it's clear that even a single day of halted rotation would leave lasting fingerprints on the planet. Geological, atmospheric, ecological, and human systems would be forever altered, reminding us that Earth's rotation is not just a measure of time, it is the heartbeat sustaining life, shaping landscapes and preserving the delicate balance we often take for granted. Thank you for joining me on this wild journey into a world where the Earth stops spinning. We've seen oceans surge, winds rage, day and night freeze, and civilization push through its limits. It's incredible to think how much our planet's rotation quietly shapes every part of life. From the air we breathe, to the oceans, gravity, and even the magnetic field protecting us. If you found yourself fascinated or a little terrified by what could happen, imagine what a part 2 could explore. Longer stops, extreme what-if scenarios, or even how humanity might survive in more detail. Don't forget to like, subscribe, and hit the notification bell, so you won't miss part 2 if it comes. Share your thoughts in the comments. What would you do if the Earth actually stopped spinning for a day? Until next time, stay curious, stay safe, and keep looking up at the spinning planet that quietly keeps life in balance.